Hello and welcome back to Calculus 2, section 8.5 on integration by partial fraction decomposition. Now, there is a pre-calculus portion to this lecture that you need to know in order to do calculus with it. And we are going to focus on that one tonight. We'll solve one example with integrals and then we'll deal with the integration. Next class we have to review, and I guess you want your test for whatever reason. So, what is partial fraction decomposition? Where is it coming from? What does it do? And all of these kind of things. So let's first start with some arbitrary rational functions, say 3 over x plus 2 plus, I don't know, put whatever, 5 over x minus 3 or whatever. So this is a standard problem that you would give to elementary algebra student to add two fractions, which are in this case rational functions. The student is supposed to find a common denominator and work this out into a single fraction, and the problem is over. So if you do that, the way I teach it, I say to students, let's play the game of what's missing in each one of these, right? Because the least common denominator is when you multiply the two. So the first one is missing x minus 3, and the second one is missing x plus 2. So when you multiply these, you will FOIL. There we go. Distribute and FOIL. We have x minus 3, x plus 2 as our denominator, common denominator. And in the numerator, we will have 3x minus 9 plus 5x plus 10. And that is going to be 8x plus 1 divided by, and we have x minus 3, x plus 2. And that's it. So this is a standard algebra problem to do. And you would box the answer, submit, and you're done. Now, partial fraction decomposition is a method to decompose, right? Partial fraction decomposition. To decompose this into 2 over here so that we can integrate. So the problems that are coming up will look like something like this. 8x plus 1 divided by x minus 3, x plus 2. This could be also, FOILed. And that is a problem. None of the methods we covered so far work on this problem. It's not basic, it's not U sub, it's not by parts. You can't do trig sub on it, right? So nothing works. We have to learn partial fraction decomposition. So the goal is to learn partial fraction decomposition first. So what I'm going to do here is I'm going to say, I'll put the blue, right? Blue is kind of soothing, cold color, right? So we don't have to, it's not threatening at all. When I put the arrow and I say algebra, right? And then I put this flaming red, like a, pits of hell kind of thing, and just say partial fraction decomposition. And this is what we need to learn if you already don't know this from your pre-calculus course. Unfortunately, in pre-calculus, that section is optional. I always teach it, but not everyone. So you might be seeing this for the very first time ever. So, and you need it, obviously, so pay attention. Let's go. How do we work out partial fraction decomposition? So first, we have to memorize 4 cases which are the setup right, for the partial fraction decomposition. And then there is a procedure, which is a calculation you have to work out, and then you are ready to solve it. So partial fraction decomposition. Case 1 is, now I am writing blah over x minus c, which will set up as a over x minus c. Case 2, blah over x minus c squared will be set up as a over x minus c plus b over x minus c squared. Case 3 is blah over ax squared plus bx plus c. Breaks down to, setup is ax plus b divided by ax squared plus bx plus c. These a's and b's are not the same numbers, lowercase and uppercase. So please make sure. And finally, case 4. Again, blah over ax squared plus bx plus c squared will give us ax plus b over ax squared plus bx plus c plus cx plus d over ax squared plus bx plus c, everything squared. This is what you must memorize if you are to do 8.5 integration. Now, these cases are symmetric, right? There are the features that repeat themselves, right, as you go from case to case. And let us first notice that for every setup you have on the right-hand side, the exponent in the numerator is by 1 less than the exponent in the denominator. So exponent in the numerator is by 1 less than the exponent in the denominator. So over here you have x to the 0th power, which is 1, and over here you have x to the 1st power. Over here you have highest exponent to be x to the 1, on the bottom x squared. So that's one of the cool things to put together. If you have the repeated either linear or repeated quadratic, you will have two of those terms on the right-hand side, and you see that the denominators behave the same way, where the second one is squared to match what you have on the left, and so on. So this is what you are memorizing as a setup. Your goal is to compute the values of A, capital B, capital C, right? And everything on the left is always given to you in a problem. So clearly, if I want to learn to decompose this, if I do the decomposition for that problem, I must get 3 and 5 as my answers, which are 3 and 5. That's what I'm looking for. All right, let's go and deal with this. So 8x, what is the procedure? Now, procedure is learned through examples. There is no theory over here. So you have to pay attention. 8x, was it plus or minus 1?
Plus 1.
And was it x minus 3 or x plus 3?
X minus 3.
X minus 3, x plus 2, right?
Yeah.
Excellent. All right. So this is my problem. Denominator is factored into two linear cases. So I am going to say that I have a over x minus 3 plus b over x plus 2. I understand that for the linear case, you have a over x minus 3 or whatever, but I have two of them. So these are two linear terms. Well, since I already used a for the first one, I will have to use b for the second one. And now we have set up the partial fraction decomposition. The rest of the problem is to figure out what those a and b are. Now we know that those a and b must work out to be 5 and 3, but let's see how to calculate this. So what did we use from the chart? We used this feature here. You have a linear term, and the setup is a constant divided by the linear term. That's it. And I used that twice. Constant divided by the linear term, different constant divided by the different linear term. So we have to use a and b. If I had another one, let's say x plus 1, there will be plus c over x plus 1. So you keep adding if you had more. Well, we don't have it, so I'm not going to do it. All right. Let's go and deal with this. The only thing I can do is to multiply everything on the right, and I will get x minus 3, x plus 2 as the common denominator, and when I cross multiply, I get ax plus 2a plus bx minus 3b. Hopefully you see that the left and the right have the same denominators, which means that their numerators must be equal. So now I can write that 8x plus 1 is equal to ax plus 2a plus bx minus 3b. I just equal the left and the right side. The denominators are the same, so they would cancel on both sides. And all I have is this. So now I have terms that have x's, and then I have terms that have constants. So this is what is going to give rise to my what I call the blue and red equation, in this case blue and purple equation, whatever. So I have 8x plus 1 is equal to a plus b x, when I factor out x, plus 2a minus 3b. And now I'm going to use my blue and see that coefficients of x must be the same and the constant must be the same. So the blue equation is a plus b equals 8. And my purple equation is 2a minus 3b is equal to 1. Do we all see where these equations came from? Simply equaling left to right side. This is a process. So, and this process is always going to be the same. You will put up the setup using the chart you memorized. Then you are going to add those fractions to get the right side, and then the left and the right will have the same numerators, which is this line. And then you will factor x's, factor x squares, factor constants, right? All of that put on a pile. And then you just equal the left with the right side. Coefficient of x must match coefficient of x, and then the constant must match the constant. So that's the way we deal with this. And now you have a system to solve. Now, whatever your method to solve this, right? We talked about it. You can use substitution. You can use elimination. You can use guess and check method, essential oils, whatever. So what I'm going to do, we can do times negative 2, we can do times positive 3. Let's do times positive 3 because whatever. So we have 3a plus 3b equals 24. Usually that's your mistake. You forget to multiply that. 2a minus 3b equals 1. We are not changing the bottom equation at all. And now when you add the two equations, the b's would cancel. I have my 5a equals to 25, from where a is 5. Hey, we were looking for a 5, right? And now you have a plus b is 8 equation, from where you get that b is 3. So now you look at your problem. It says a and x minus 3. A and x minus 3 plus b x plus 2. So this is your a, and this is your b. Now let's see. 5 needs to be with x minus 3. 5 is with x minus 3. So decomposition was successful. That's it. This is the cheapest problem you can have, because all we have in this case are two linear terms, two case 1s, right? Two case 1. And we plow through these calculations. We get what a and b are and plug them in to come up with the answer. So now we are done with the decomposition, and we move on. Let's work out another decomposition. Again, if you want more practice, if you have your pre-calculus book, look into chapter 7. You will find the section 7 point something, whatever it is, and you will have just this portion, obviously no integrals. Let's take a look at another problem to decompose. Now this one will be a little bit more involved. We have 3x squared plus 7x minus 2 divided by x cubed minus x squared minus 2x. So this is our next problem. The first thing you have to do is factor denominator. You have to factor it completely. The first thing we do is we kick out an x, leaves us with x squared minus x minus 2, and then you factor that one into, in this case, x minus 2x plus 1. Is that bueno? That's good, right? What I have, again, are three case 1, right, for the setup. I have a over x, that's linear. You can write it as x minus 0 if you want to, but it's just x. Plus b divided by x minus 2 plus c divided by x plus 1. You can list these in any order you want. It doesn't matter. Your constants will always come up to be. Like if number above x minus 2 is 7, doesn't matter which x minus 2 is, 7 will always be above x minus 2. You can't be anywhere else. So you have to know that which order you put them in, it doesn't matter. At the end, it will sort itself out to give you the correct number for whatever is above x and whatever is above x minus 2 and x plus 1. Cool. The next thing for us here is, after we do the setup, which is what we memorized from the chart, the next thing for us is to add those fractions on the right side to come up with the denominator, which is the common denominator on the left. And then on top, we're going to have some mess that we'll have to do the sorting, right? So now, what do I need to multiply a by? Well, I need to multiply by x squared minus x minus 2. right? Because that's what I have when I multiply just x. What do I need to multiply the middle by? I have to multiply by x times x plus 1. Does that make sense? Because this is your common denominator. If you have the first one, then you need to multiply the other two into a. Then you have this one, you need to multiply by these two. And finally, for c, we have a c, which is x plus 1. I need to multiply by these two, which is x. Let's go different color. X minus 2, x minus 2. Now, good thing is that we don't have to worry about denominator at all, because denominators always cancel. We can just worry about numerators. So 3x squared plus 7x minus 2 is going to be equal to, and now we have to multiply that out. So we have ax squared minus ax minus 2a plus bx squared plus bx. That's when you distribute bx into these ones. And now you're distributing cx. So plus cx squared minus 2cx. So these are all of the numerators. Here are the first with the orange. Here are the two that are blue. And the last two are green. So these are the orange ones. These are the blue ones. And the last were the green ones. That's where they came from. Just simply multiply those out. Now we do the factoring. 3x squared plus 7x minus 2 equals 2. Now we need all of the ones that have x squared. Well, that's simply a plus b plus c x squared. Those are done. Now I need plus all of the ones that have x's. That's this one has an x, this one has an x, this one has an x. So negative a plus b minus 2c. And finally, the constant terms. Well, there's only one constant term, negative 2a. There are no other singles. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Good, we have them all. Now we compare coefficient of x squared with the coefficient of x squared. Coefficient of x with coefficient of x. And finally, constant to a constant. I have a plus b. Maybe I can use the blue one. A plus b plus c equals 3. Oh, I forgot to put x. Yes, thank you. No, it's negative a. Why would it be negative 2? Is it negative 2? No, it's not. It's positive. Okay, it's negative, just negative a. Negative 2a is over there. All right, cool. So now we have negative a plus b minus 2c is equal to 7. And the orange equation is negative 2a is equal to negative 2. So that's our system. 3 unknowns, a, b, c, 3 unknowns. Well, we have 3 equations, so go ahead and solve it either way. Now, good thing is we have one of them for free. And that is what? A is 1, right? That's free. So we are immediately going to plug that in and reduce the system to 2 by 2 system. We'll have b plus c is equal to 2, and b minus 2c is equal to 8. You know, when a is 1, you will subtract 1 on both sides and you will get a 2. And when a is 1, that becomes a negative 1. You have to add 1 to both sides. Now, you are also allowed to subtract equations. You don't have to multiply the top by 2 to kill off c's. Your b's are already lined up. Just subtract equations, because subtracting equations is equivalent to multiplying one of the equations by negative 1. That's why you are allowed to subtract equations. Those of you going to linear algebra will learn that really well. So we can subtract equations, and it doesn't matter whether you're going to go 2 minus 1 or 1 minus 2. Even that doesn't matter. So when you subtract equations, b minus b is 0. C minus 2c is 3c. And 2 minus 8 is negative 6. So we calculate that c is negative 2. I already have that a is 1. So if c is negative 2, b must be 4. Because when you plug in negative 2 over here, move it to the other side, becomes a plus 2, and 2 plus 2 is 4. We're done. That's it. We have a over x. So that's 1 over x plus b is 4 over x minus 2. And then minus 6, no, lies, minus 2 of the x plus 1. If this was wrapped into the integral, you are integrating those three. What's the first integral? Absolute value of x. Yeah. You're gonna spin it the other way, and it will be on point. Yeah. How about the second integral? If that was an integral, this one, what would that be? That would be 4 ln absolute x minus 2. And then the last one would be negative 2 ln x plus 1. So you will be solving those integrals just by looking at them, because every single problem will either be u substitution, basic ln, or inverse tangent. Those are your three options at the end of each one of these partial fraction decomposition integrals. ln, u sub, or a trig, the inverse tangent. Right? So your problems will work out to be somewhere in that range to finish off the problem. But this is partial fraction decomposition, so let's work more on pre-calc before we hit the calculus waters. Let's see if we can find something different. Ooh, shiny. Problem 15 has x divided by x to the 4 minus 16 squared. Oh, this is going to hurt. We have to factor this. Well, x to the 4th minus 16 is going to be given as x squared minus 4 and x squared plus 4. And because there was a square there, each one gets its own square. Are we agreeing on that? Good. But then this one can break further. So we're going to have x over x minus 2 and x plus 2, and each one is squared. And now we have this quadratic that we cannot break any further. There it is. So now, if you are to look at that chart in your notes, if you look at that chart and you look at these ones, what do you have? I need you to tell me case, and then you tell me a number. For the first one, case, tell me a number for the second one, and case, tell me a number for the third one. So what's the case on the first one? Case 2. How about the second one? Case 2. How about the last one? Case 4. Case 4. It's a quadratic function that you cannot factor any further. It doesn't have that middle bx, but it doesn't matter. You can have any of those missing. But it's squared. So, yeah, I'm not calculating this. No way in hell. It's going to take us a day. How many variables are we going to have here? The answer? A lot, right? The first one is repeated quadratic. That's going to be A and B, right? Because we have the case 2. Then the second one, repeated linear, so another 2. And then repeated the one at the bottom, it's going to be 2 plus 2, it's going to be another 4. So we're going to have 8 variables. You're going to have 8 equations with 8 variables to solve this, and that's what the software is for. We don't solve that by hand. I mean, we could, but, you know, there are things in life that we can do instead, right? So let's go. We have A over x minus 2 plus B over x minus 2 squared plus C over x plus 2 plus D over x plus 2 squared. And finally, plus, we have the third one, which is going to give us another 4 terms here. We have ex plus f divided by x squared plus 4. Let's use g and h plus gx plus h divided by x squared plus 4 squared. There you go. We have 8 variables in this case to break it, and now there is that long procedure of figuring out all the common denominators, whatever is missing, multiply by that. So this is going to take hours of work to work it out. On exam, you either have a 2 case or a 3 case. That's it on the exam. Now, generally what I have on exam 2, because this is exam 2, I have 2 problems from partial fraction decomposition. One is a 2 case or a simple 3 case like we just had when you get one for free. And then I have a problem just like this, which says, set up, do not solve. And that's my favorite problem. Because we are bound to have those that are not paying attention, right? And they say, can I have a scrap paper? No. Every other page is blank, right? And then for the rest of the exam, on all 4 back pages, there is a calculation hoping to solve this and asking me after the class, why was that problem so insane? The problem is 1 line. I said, set up and leave, right? Now you're trying to solve, and I'm going to leave like this much space, right? You're going to have like 3 fingers of space at most on the bottom of the page to solve that problem, right? This is going to take hours, right? You can see that. Because first we have to come up with this by multiplying between 8 variables, right? That's going to take a landscape and another page next to it taped, right, to put the expression if you want it in 1 line. Then factor everything. You are going to the x to the 8, and then x to the 7, and x to the 6, and x to the 5, and they all have to match with the other side. That will create, x to the 7 will be the highest, right? Because you have 7, 6, 5, you need to have 8 of them for 8 variables, 8 equations. Yes. So x to the 7 will give you an equation, then x to the 6, and x to the 5, and 4, and 3, 2, 1, and the constant at the end. And you will have 8 equations, and then you reduce that into a 7, then into a 6. If you're doing this, let's say you are at NGIT and you're doing this problem by hand because no calculator is allowed. So good luck, right? I'm just going to draw the line here and move to the next example because that's what we do. Let's see what else could be very interesting. The problem says do not find the values of the unknown constants. Pretty much telling you that you are doomed if you try. I mean, you can do it. It's just... Now, here is a problem that they actually want you to compute all the way. So let's see what is in store. I already don't like it, but... problem 61 is expecting you to compute partial fraction decomposition. Actually, you know what? This is going to be our first example that contains... first example that contains an integral. So we have to do partial fraction decomposition, and then we're going to integrate and solve everything. So here we go. And then we're done for today. We'll do the review. The question simply says integrate. So you tried everything else failed. You can do U sub, you can do by parts, you can do trig sub. So everything failed, and you are, or maybe trig sub would work here. It's a tangent substitution, but let's say we don't know that. Partial fraction decomposition. We are going to isolate. It's already factored for us. You should send a thank you note to the author of the book. And we have to set up. We have a over x. That's the linear term, case 1. And then what do you have here? You can't factor it, which means it's one of the quadratics, and it's squared, which means case 4. Very good, case 4. So there's going to be bx plus c over x squared plus 1, and then plus dx plus e over x squared plus 1, everything squared. So that's your life. 5 variables. They are expecting you to compute this by hand because it is in the form of the integral. So let's see how nasty this actually gets. The easiest one, obviously, is at the end. You just need to multiply by x top and bottom. That's the only thing that it's missing. Everything else is worse than that. The middle one, we are multiplying by x times x squared plus 1. And x times x squared plus 1. And the first one we are multiplying by x squared plus 1 squared. Now, it is good to FOIL this. So x squared is going to be x to the 4th plus 2x squared plus 1. So that's what we are multiplying by when we do the orange. And we have x cubed plus x when we multiply by the blue ones.
I have a question.
Yes.
For the red, why don't you multiply by x squared plus 1 again?
Well, when I look at my common denominator, right, I already have x, and I just need the second part. I only multiply. So over here, I need this, and I need this because that creates x plus x parentheses squared. And then I have an x as well, right? So you just multiply by what's missing to get into the common denominator. Just the parts that are missing. All right, so I have 2 equals. Yes.
I actually have a question. That part where the numerator is bx plus c, what's the point of doing that part if you have it right next to it, the same thing but squared?
Well, that's the setup from our chart, right? That's from the theorem. You can see it right here, right? Our case does not have bx, but that's okay. You can have that one missing. It's fine. We have to have both of them for the repeated ones when they are squared. That's the part of the theorem. All right, let's go and see. Multiplying a by the orange one. So I'm getting ax to the 4th plus 2ax squared plus a. Then I have the blue one. Now the blue one is going to this FOIL, because I have all of this times all of this. So that's going to give me 4 terms. I have bx to the 4th plus bx squared plus cx cubed plus cx. So those are my blue terms when I multiply that. And the easiest ones are the red ones at the end. Plus dx squared plus ex. That's easy. So there they are. We are going to now factor everything. And I'm going to put equals 2 on the right side. So let me just factor all of these. So where are my 4s? I only have a plus b is equal to, a plus b in parentheses, I'm factoring for the x to the 4th. Plus, now I need a parenthesis for cubes. Oh, isn't that just c for the x cubed? Well, that's nice. Plus, I need a parenthesis for squares. I have 2a plus b plus d x squared. Now I need a parenthesis for single x's. I have a c plus e. C plus e, and that's a single x. And then just a constant, and that's just a, equals to 2. Now, what is this 2? Well, that's just a constant. You know what I'm going to do? I'm going to do this now. To explain this 2, I'm going to say 0x to the 4 plus 0x cubed plus 0x squared plus 0x plus 2. That's what it means. So now I can match. For my red equation, I have a plus b with a 0. My blue equation, c is 0. My green equation, x squared and a 0 for x squared. My orange equation is 0. And finally, purple, a is 2. So red equation, a plus b equals 0. Blue equation, c equals 0. Green equation, 2a plus b plus d equals 0. Orange equation, c plus e equals 0. And finally, the purple equation, a equals 2. Yeah, this worked out really nice. This worked out really nice. We got 2 of these for free. C equals 0, A equals 2. Those are free. And now when you plug in C equals 0 here, you also get E equals 0 free of charge as well. Now if A is 2, B must be negative 2, no coughing, because they have to add to 0. And the only variable that I need to calculate, right, is D, right? I have A, B, C, D. I am missing D. So what's D? D is 2 or negative 2? So we have 2 times A, 2 times 2, plus B, which is negative 2, plus D equal to 0. That's 4. Minus 2 is 2. D is negative 2. Yes, you are right. So you gotta chase these things around a little bit to get all of the constants. And once you have all of these constants, any one of these that is 0, you just don't write it in those setups up there. So a over x, how much is my a? 2. I have integral, open parenthesis, 2 over x, plus bx plus c, negative 2x plus c, c is 0. I am not worrying about that one. And I have x squared plus 1 on the bottom. Plus the last one is what? Dx plus e. Dx plus e is 0. And I have x squared plus 1 squared. And then I have dx.
Is D a negative 2? Not 2?
Yeah.
D is negative 2, yes. Oh, that's going to change. Okay, so that's a negative, and I'm just going to fix this one as a negative. There we go. Perfect. Simple U sub, very good. Simple U sub. It's tempting to pull that 2 out, but we need it for the U sub, so just leave it alone, right? Time to do the U sub, where U is x squared plus 1. Du is 2x dx. And we have integral of, well, first one is ln, so we're just going to do 2 ln x, absolute x. All right, that's the first one. And now we have minus the integral of, and this becomes just du over u, minus another integral of du over u squared. And I put the blue ones because we did the u sub for those two. So the first one is 2 ln absolute x minus ln of absolute u minus, and now when you integrate this, you're going to get negative 1 over u plus c, and then you bring the u's back. So 2 ln of absolute x minus ln of u, which is x squared plus 1, plus 1 over x squared plus 1 plus c. Welcome to partial fraction decomposition. It is a procedure, very tedious, very annoying, cheap and easy as hell. This is really cheap and easy, but it's really annoying and really long procedure. It is only one procedure. There are no special things to learn. You need to memorize those 4 setup, and once you figure out the procedure, you will just be plowing through these problems. At the end, which we are going to do more examples, obviously, after the exam on Thursday. At the end, you are looking into basic ln integrals, u sub, which we just have, or inverse tangent. It is very easy to end up with something that looks like, integral of 3 over x squared plus 4, or something like that, right? That's inverse tangent. It's very easy to come up with something like this at the end. So you can also see an inverse tangent problem as well. So we are going to leave it here, take a 2-3 minute break. When we come back, we are going to talk about the review.